Alright, here we got like a series problem again, where n is from 0 to infinity and, well, of this. Right? And x is going to be like the values for convergency for this series. So like it's an interval from y to z, like constants. That's all like the numbers x can be to make this series convergent. You know what I'm saying? Like ouch. Let's get to the problem. All right. So to find convergency, when there's like a x inside of the series, it's kind of weird. So it's easy to use the ratio test to like make this more beautiful. Yeah. So ratio test, remember, it's you just write this over here, but every n you do n plus 1, and then you multiply it by this flipped over. It's reciprocal with no n plus 1. Here, I'll write it out. And the reciprocal I'm talking about is you kind of leave the n's regular, but just flip it. Like the 2n factorial is going to be on the top. And the numerator is going to flip to the denominator. And it's all absolute valued. Okay, we can simplify this. The 2n's cancel. X minus 2n's cancel. And don't forget about these 1's. That's all right now. So 2 is still there. X minus 2 is still there because of the 1's. And this down here gets simplified to 2n plus 2 factorial. And then, well, that's all gone, so it's just 1. Oh, whoa. All right, and a good way to simplify these, like the factorial ones, because that's the next step, is to, here, I'll just write it out. You could multiply that out or not. I mean, I'm not. I know it looks weird. You just don't got to. Okay. So 2n plus 2 factorial is the same thing as 2n plus 2, 2n plus 1, whoa, times 2n factorial. So like the factorial is just for 2n. And as you can see, these two cancel out. And we're left with paper holder. There we go. So left with that. I am. So we're left with this. And we could bring the x part out because it is no like relation to the limit, which is using n. So we could just bring the x and the constant, or we could bring the 2 out as well. So it's going to equal paper holder. Okay. make sure that you put the absolute values, because the x, you know, it's gonna go crazy. Here. Okay, we're gonna run out of space here. And we could take out the absolute values for these ones, since well, n is from, like, the n is from 0 to infinity, so it's never gonna be negative. And all we got left in this little parentheses bundle right here is n and positive numbers. So yeah, it's fine. All right, and limit, we could do the limit just straight up. If you plug in infinity down here, everything's gonna equal 0. So we're gonna get times 0, which equals 0. And for a ratio test to be true, it has to, if you can get down to the final result, it has to be less than, or not equal to, just less than 1. And whatever x is, it's always going to equal 0. So x can be any real number. Any real. Okay, paper order. Any real. Dang, my handwriting is terrible. X can be any real number.